Okay, welcome back. So in the previous lecture, we had spoken about data warehouses and how they are used to derive business intelligence in an organization. Today's lecture will focus more on data mining and its various applications. Why data mining? Because data mining, we had discussed, is one of the important tools that is used to derive business intelligence from data that is stored in the data warehouse. So this speaks all about why data is required in organizations. In God we trust, all others must bring data was mentioned by W. Edward Deming. And who is he? He is a great engineer, statistician, professor and a management guru. So without data, nobody will trust you. So the world is all about data, and data is supposed to be the gold today. So moving ahead, this is an insight from MIT Sloan Management Review, which came in 2010, 10 years back, which says that there is a striking correlation between an organization's analytic sophistication and its competitive performance, which is very, very obvious in today's date, because every organization is producing huge chunks of data. So if you don't have the sophistication or the capability to analyze that data and use it for deriving your strategies or making your business decisions, you will lag behind your competitors. So if you have better sophistication in analyzing your organizational data, that will obviously lead to better competitive performance of your organization. So this is very true in today's state. Harvard Business Review 2012. So this is very important for all the aspiring managers who would want to be data scientists in future. So 21st century is going to be all about data science. So all of these make us think, why is there so much of hype about data mining? Why do people mine data today? Why didn't they? Nobody spoke so much about data mining, say 15 years back. So the reason lies here. Huge amounts of data are being collected and warehoused everywhere around us. Earlier, nobody thought about collecting so much of data. We did not have the technical sophistication, the storage space, the processing power to handle so much of data. But today we do have. So for example, Walmart collects and records 20 million items in transactions per day. 20 million Walmart alone. Healthcare transactions produce multi-gigabytes of data. And of course you would realize that in the times of COVID-19, analyzing healthcare analytics has become so very crucial, so very important, because without healthcare analytics we would not be able to predict trends, we would not be able to find clusters of red zones which are highly susceptible to the coronavirus. So healthcare analytics is not only used in COVID-19 scenario, which is a pandemic, it was also very popular, it was used a lot for multiple diseases, because huge amounts of data are being collected on the fly, healthcare data being collected on the fly and being analyzed on the fly. Today all of us wear smartwatches. So smartwatches collect data on human being about your health related data continuously and stores it somewhere, right? Stores it and you can analyze that data. So that is why, since huge amounts of data is being collected and warehoused, therefore why not mine that data, because data is gold, right? So as gold is, there is gold mining, similarly data mining would actually help you in in coming up with insights which are not at all less precious than gold today, right? They are not less precious than gold. Moreover, mining of data has become very important because data is a source of competitive advantage for every firm. Firms have a lot of data, so if you analyze your data better, and if you help make better data will help you make better decisions, data will help you come up with better strategies, and all of that would give you a source of competitive advantage over your competitors. So, moving ahead, we have often heard about the term data mining, but are we aware of its actual exact meaning? Along with that, today we will also discuss another very important term called KDD, knowledge discovery in databases. We will also try to understand what the difference between the two terms is. So, what is the difference between data mining and KDD? Knowledge discovery in databases is the non-trivial process of identifying valid, here I would be highlighting a few points, valid, potentially useful, understandable, and ultimately actionable patterns in data. So, KDD is the non-trivial process, which means it's a very significant process of identifying valid. So, why did we highlight valid? Because there could be a lot of patterns that you could get from data, because as we mentioned, the data is getting collected on the fly, huge amounts of data. So, there could be a lot of patterns which are irrelevant to you. They are not valid, they are not relevant. For example, if I say that there is a relationship between the number of trees in my neighborhood and the number of pens I possess. So, my limited understanding tells me that there is, it could not be a relevant pattern. I cannot derive much insight or value out of this pattern. So, patterns that are derived should be valid or relevant, potentially useful, which is why we actually go ahead and mine data. So, they should be potentially useful, understandable. Why? Because there could be a lot of patterns which are not easy to understand, and even more important, not actionable, right. So, if you come up with an insight, or if you come up with the pattern based on which you cannot take any action, it's just a pattern, but it's a pattern out of which an organization cannot take any action, then that is not knowledge discovery in database. So, that does not amount to it. So, what should happen is, ideally, the pattern that we find out should be valid or relevant, of course useful, understandable, so that the data analysts or the business persons are able to understand the pattern, and they are able to take some action based on the pattern. That is, you either take some business strategy out of the pattern, or you make a decision out of that pattern. For example, if you get a pattern that there are a group of users for a telecom provider who are at a high risk of churning, or who are at a high risk of switching to another provider. You can take an action based on that. You can either give him some incentives, or you can try to give him some lucrative offers to retain him, or if you think the customer is of extremely low value, you can let him go. So, here we have a pattern, or we have a finding or an insight based on which we can take some action. Therefore, it is very important to be able to take some action based on the pattern that we derive. Now, data mining is just a step, and it is very important why I highlight this. It is just a step in the KDD process of applying data analytics and discovery algorithms. So, KDD is a huge process. Out of that, data mining is only a step of finding some patterns. So, what are the other steps? Let us have a look. So, here this schematic diagram will explain everything about data knowledge discovery in databases and where data mining stands. So, here we see a small factory. It could be a factory, or it could be a departmental store, it could be any departmental store that we see around us, wherein there are huge amounts of data being produced every day, transactional data, storage data, warehousing data, distribution data, a lot of data being stored every day. Now, that raw data from the from the store, departmental store, gets extracted, transferred and loaded from the multiple databases of the departmental store, as we had discussed in the previous lecture. All of them now get loaded into the data warehouse. So, from the data warehouse, the next step is selection and cleaning of data. Selection, because there could be a lot of data that you collect from the departmental store, but not all of the data would be relevant to you. Earlier also we had said that the data should be relevant. So, you select only the relevant data that is suited to you and you then clean the data. So, what is data cleaning? Data cleaning also amounts to, it's a part of pre-processing of data, wherein you take certain actions, such as, you may want to remove some outliers if your data has a lot of outliers, or you may, if your outliers is the presence of outliers could be skewing the data, so you would want to eliminate the outliers, or you could be having a lot of missing data, incomplete data. So, you may want to take care of that or tackle that problem by either dropping some of the records that have missing data, or taking an average of some of the records of the records, which the attribute which is having missing data, and then filling the missing cells. Or there are multiple ways in which missing data is handled. That itself is a could take 3-4 lectures, but we are not getting into that. So, our post selection of data is cleaned, as we have discussed, and the selected cleaned data is called the target data. So, the target data is the data on which the transformation operation is then performed. So, what is this operation called transformation? It is another very important operation in which data is transformed from one format to another. There are a lot of, let me give you some examples. So, for example, you could have data in Fahrenheit, so temperature data in Fahrenheit, but prior to analysis, you would want to change it to Celsius. So, that is one way of transformation. Similarly, say you have 2 attributes, but you do not want to use those 2 attributes for your analysis. Rather, you would want to use a third attribute which is derived out of these 2 attributes. So, the third attribute is called a derived attribute, and the derived attribute or the transformed new attribute is going to be used in your analysis. For example, I may have GDP data of multiple countries and the population. But I would want to use GDP per capita as my variable. So, what I would do is input variable. So, what I would do is I would use these 2 attributes, GDP and the population, and find a new attribute called GDP per capita, which is the derived attribute that I will use in my further analysis. So, there are a lot of other examples such as logarithmic transformation, which is used for data sets, maybe which are distributions which are highly skewed to reduce the skewness prior to data mining. So, these are certain examples of transformation. There are a lot of other examples of transformation, but they are very context specific, and I would not want to discuss all of them here because they are beyond the scope. Now, post transformation, the transformed data is then mined. So, here we see that out of this entire process that we see here, data mining is just one step. It is just one step. It is one step, it is the particular step of finding patterns and rules in the data. So, now the transformed data is fed to some algorithms are run on the transformed data, and you do identify some patterns and rules out of the data. Post which, once you find out the patterns or rules or the outputs of the algorithm, the output is interpreted and evaluated to derive knowledge. So, finding the output is not enough. The data analyst has the role of interpreting and evaluating the output to derive knowledge out of it. Post the knowledge, it is very important to understand how this knowledge can be useful for the organization. So, this is the step where finally understanding and integration happens, or the knowledge that you derive out of the entire out of the process is now transformed to something that is actionable. And that actionable output or knowledge is now sent back to your departmental store so that it can add some value to the departmental store. This entire process is called knowledge discovery in databases, and data mining, once again I would like to reiterate, is only a step. I hope the process of KDD and the role that data mining has in the KDD process is now clear. All right, so let's move ahead, and here this particular slide talks about the fact that data mining is multidisciplinary. So, data mining draws from different disciplines. As we see, of course, database systems play a very important role. We saw the entire data is stored in databases and then sent to data warehouses, from where we are actually using the data for data mining. Statistics and machine learning both play a very important role in analyzing the data to come up with outputs. Of course, data mining is multidisciplinary and draws from different disciplines. Moving ahead, let us see some very interesting applications of data mining in the business context. Customer segmentation in marketing, very important role played by data mining. So, what are my market segments and who are my customers by segment? So, you find out your market segments and then you find your customers who reside in each of those segments, post which what you do is personalize customer relationships. So, if you know who are your customers by segments, you could give them appropriate strategies. Propensity to buy is another area where data mining has a very important role. Which customers are good candidates for our new long distance calling plans, very important for telecom sector. So, targeting customers based on their needs, that is what you need to do. Profitability modeling and profiling. So, what is the lifetime profitability of your customers, of my customers? So, once I understand the lifetime profitability of my customers, I would be able to increase high value customers based on current and future profitability. And if I see there are some low value customers, I may either try to convert them to high value customers, or if I see that there is no value, I may actually let them go. Another very important application is in predicting customer attrition or churn. So, who are my most valuable customers who are at a risk of leaving? If I can understand this, I can try to prevent the loss of high value customers and let go of lower value customers. Channel optimization. What is the best channel to reach my customers in each market segment? So, this is again very important. Finally, fraud detection. So, data mining, there is a huge section of data mining that is dedicated to fraud detection. So, we see fraud all around, right? In marketing there is fraud, in finance there is fraud. So, fraud detection and data mining go hand in hand. So, how can I tell which transactions are likely to be fraudulent? So, if I can predict transactions that are likely to be fraudulent in future, I could take a lot of measures to detect and prevent the fraud in order to minimize loss. So, if there is fraud, of course, there is a lot of loss to the organization. So, it's very important to try to detect the fraud a priori so that measures can be taken to prevent the fraud. So, these are certain applications. Now, here industry-wide applications of analytics. Here we see that in every domain, manufacturing, retail, healthcare, service, banking and finance, IT, ITES, everywhere analytics and data mining play a very important role. Moving ahead, here there are some other applications which I would really like to focus on. In marketing, which customers are likely to respond to a particular campaign. So if you know that, you can, so in the world of digital marketing, this is very important today, because every organization is into digital marketing. So if you would be able to predict the customers that are likely to respond to a campaign, not only in digital marketing, in the world of physical marketing also, you can target the campaigns accordingly. Which customers are likely to be profitable? Of course, very important to know. Who might want to buy a particular product? So if you want to cross-sell or sell or upsell, so either you want to sell some complementary products to a customer who has bought a certain product, or you would want to sell some higher value product. If you can predict, you can target accordingly. So that helps in, wasting a lot of calls or, a lot of money on targeting customers who might not be interested at all. Right. Similarly, in, there are a lot of other applications of data mining and analytics in marketing. In telecom, of course, we had already discussed which customers are vulnerable to attrition or at a risk of churning. So this would help us in identifying them and in order to devise strategies to prevent them from churning. Based on these symptoms, where are problems located in the network? So if there is a section of, of a zone, a particular zone or a particular region where customers are churning more, we would be able to identify that, look into deeper into that particular region and check out the network problems that could lead to the churn. In finance and insurance, again, analytics has a very important role. So which customers are credit risks or insurance risks? So you may then decide whether you would want to, let the customer take a policy or let the customer take a credit based on the risks. Which claims or credit transactions are fraudulent? Very important, right? Similarly, there are a lot of other examples in finance and insurance. Healthcare, we have discussed that, in the world of COVID-19, healthcare analytics plays a very important role. Otherwise also, in the world of healthcare, analytics has a major role to play. So which patients may take longer to recover? What is the likely cause of a particular illness? Which patients are at risk of disease? So for example, Pfizer Pharmaceuticals used data mining to construct a predictive model that was then embedded in their online cholesterol health risk assessment, which tells patients their cholesterol risk score. So once you know your risk score, you can take measures as to not eat that egg that you would like to eat every day. Okay, so jokes apart, coming back, in retail, analytics help, or data mining would help you find out which products do customers buy together or which products they do not. So this would again help you come up with strategies. So I'll discuss this in detail in one of my subsequent lectures. So what can you do if you find out that certain products are purchased together and certain products are not? What characterizes customers at various stores? What type of customers buy certain items or product type? Which items are generally bought with cash, which are bought on credit cards, on credit, or which are bought by check. So if you know if you have such insights from data, you can take measures a priori, which would help you minimize losses later. Quality control, very important, because all organizations today take measures to control quality of their products or shipments. Very true for e-commerce companies today. So if you know that, especially in the marketplace model, where many a times, the marketplace provider has to keep a tab on the quality of the product that is shipped by the supplier. So for the marketplace provider, it's a lot of consumption of resources in terms of manpower, time, etc., to inspect each particular shipment for quality. Therefore, if analytics could predict in some way shipments which are at high risk, then companies could actually try to check only those high risk and medium risk shipments, and maybe not check the low risk shipments. So this would save a lot of resources in terms of time, money, manpower, etc. And again, in customer control, customer support, everywhere there are a lot of examples here. I think you can go through them. So here also data mining and data analytics play a very important role. So here we have extensively discussed a lot of areas in business where data mining and analytics play a very important role. Moving ahead, some real life applications. The earlier ones were also real life, but these are, this is taken from a particular website. So here, this is a website called Big Basket, which is a very popular online grocery delivery platform in Indian context. So they have this feature called Smart Basket, which is a feature. It's a collection of products that you spend on most, or buy most. So what happens is, when you are trying to shop grocery from this particular forum or platform, and you would want to maybe you have shopped for, you are a regular here. So one particular day you miss out some products that you regularly shop in general. So this will give you, this will prompt you, and this will use analytics to say that, to find out that this particular product is something that you shop regularly, but today you have missed it out. So it will give you a prompt, so that if you have actually forgotten, you may quickly want to include that in your basket. Similarly, in other, Flipkart is another very popular e-commerce company in India, homegrown Indian e-commerce company. So in Flipkart, analytics again plays a very important role. So you can forecast demand for each SKU in advance. So that would help you warehouse and manage inventory better. You can predict customer cancellations and returns. This is very important, because e-commerce companies in general lose a lot on product cancellations and returns. So research suggests that 30% of products ordered or purchased are returned to e-commerce vendors. So if you can predict customer cancellations and returns, you may take measures to minimize or to reduce those cancellations and returns, and that would help you prevent losses. Also, you can try, at Flipkart, analytics is used to predict what a customer is likely to purchase in the future. So if you know that, you can store accordingly, you can recommend those products to the customer, so that there is a higher probability that the customer actually purchases. Again, at Flipkart, the entire delivery system is optimized using analytics. So that helps in saving time, that helps in better scheduling, and that helps keep your delivery persons happy, because delivery personals have a very important role to play for any e-commerce vendor. So if they are happy, your customers would be happy, and your business would be happy at the end of the day. All right. So finally, this is called the diaper beer syndrome. So this is an area where analytics or data mining predicted something that was out of the blue, that nobody had thought of before, and this is an area, this is a classical case of the role of data mining in business. So this explained that when you have a lot of data, you can come up with patterns which are unthinkable, and but actually happens, and that can help you in deriving huge benefits. So it's part of folklore of data processing. A retail chain put all its checkout counter data into a giant digital warehouse and set the disk drive spinning. Out popped a most unexpected correlation. So it was not at all expected, it was unthinkable, but it popped out. Sales of diaper and beer. What turned out is that young fathers would make a late night run to the departmental store to pick up Pampers and get some Bud Light while they were there. So this, let me explain this a little more. So evidently, when data from departmental stores in a particular region was analyzed, it was found that especially or specifically on Friday evenings, late night, when young fathers would visit departmental stores, they would buy diapers and beer together. So this was a pattern which was unexpected, absolutely unexpected. Some way, you may even think it as a spurious correlation. But what turns out is there's a reason behind this, or it's part of a folklore, of course, but it's very important to know the reason behind this. So it was, people take a lot of guesses, but in my opinion, the most possible reason could be that young mothers wanted to party on Friday evenings, leaving the young fathers to babysit. And while babysitting, they would definitely have to purchase diapers, and along with it, to entertain themselves, they would purchase some beer. So this was a incredible insight or unexpected insight, unexpected correlation that came from data analytics. And based on this, it was found that these two products, beer and diaper, were purchased together, and this drove a lot of marketeers to devise a lot of strategies for store layout in certain departmental stores. And we will discuss those strategies in the subsequent lectures. All right, thank you. So in this session, we have discussed knowledge discovery in databases and what data mining is, the definition of both the terms, the difference between the two, and we have also discussed a lot of applications of data mining in the context of business. In the next lecture, we will talk more about the various categories of data analytics and the various techniques of data analytics with their appropriate applications. Okay, thank you. Till then, see you around.